Perpendicular lines. Parallel and perpendicular. Yeah, you can put those in. All right, so parallel, perpendicular. What's parallel mean?
Lines that will never cross.
Okay, that's very close. They have to be coplanar. They have to be the same plane. Okay, which I'm assuming that you mean that, but we want to make sure on your test and quizzes. I'm going to add one of those. I think it was on the last quiz. Said like always, sometimes, never, or true or false, and it said parallel lines are lines that never intersect. That's false, because when I say two lines that never intersect, they could be skew. One could be coming at you, and one could be going like that, right? So those are not parallel; those are skew. So we would want to change that statement to two coplanar lines that never intersect. Are those always, sometimes, or never parallel? Those are always parallel. Okay. What's perpendicular mean? To form right angles. Okay, so we're going to need right angles when we talk about perpendicular. Okay, first couple theorems here just talk about relationships with a series of parallel lines. And basically what this first theorem says is if you have a series of lines that are all parallel to one another, then you could pick any two of them out and say that any two are parallel. Okay, and it's essentially the transitive property with parallel lines. And we're saying if two lines are parallel to the same line, if two lines are parallel to the same line. So here we see A and C are both parallel to B, right? Okay, so if A is parallel to B, A is parallel to B, and B is parallel to C, what can you tell me then? What's the conclusion about A and C? They're parallel as well, right? Does that seem like it's almost like elementary or very trivial, very self-explanatory? Okay, and a lot of your theorems are going to be that way, where that makes a whole lot of sense. But the benefit of that is allow me to now later on in other statements make that conclusion very easily. Okay, make that argument very easily. Okay, if you take the lines on the ceiling or the grid over here on my screen here, okay, any vertical line that I choose. Maybe I choose that vertical line right there, and then maybe come over here and choose that one, okay? Because they're all parallel, then those two are parallel, right? Does that kind of make sense? Okay. So let's think about roads in the city or suburbs. Anybody ever been to New York City? Okay, New York City is, Manhattan is designed this way, where you've got a bunch of parallel lines. All right, so here's an aerial view of Manhattan, okay? And if you look at the streets here, that street right there, parallel to that street there, parallel to that street there, right? So any one of these streets I choose, I guess that's maybe a terrible color for me to, looks real good on my screen. But any one of those streets that I choose, any two of them are going to be parallel. Does that make sense to everybody? Okay. Now, civil engineers, there's reason for doing that. Civil engineers are engineers that do like city planning or working with like infrastructure, like roads and like water pipes, sewage pipes, that kind of stuff. Okay. And keeping a city structured this way makes the allocation of those things like water and sewage, it makes that simpler. Okay, it frees up some of those resources. All right, so perpendicular. Okay, perpendicular lines are two lines that intersect to form right angles. Okay, two lines that intersect to form right angles. The symbol that we used, instead of having to write perpendicular out, we use that upside down capital T, and we just read that as perpendicular too. So in that diagram right there, we've got AB, line AB perpendicular to line CD. Now, as we work through perpendicular lines, Okay, it says they are lines that form right angles. So, how many right angles do we form? So if I have line A there and line B, if I tell you that that angle right there is a right angle, what do you know about this angle right there? Why? Okay, vertical with the other right angle, so they both got to be 90, right? What about that one there? It's got to be 90, why? Supplementary with either of those other two, right? Okay, so all four of these become right angles. Okay, now when you see a picture drawn in your homework, or really any of my notes from here on out, I'm not going to draw it this way. I'm not going to put all four right angles there. I'll draw one of them, and then you infer that the other ones have to be right angles as well. Okay. So we have things called perpendicular bisectors. Perpendicular bisect. This is the combination or the merging of two vocabulary words. Okay. Remember, perpendicular means right angles. Bisect means two parts, right? In the mathematical context, it means two congruent parts. Okay? So a perpendicular bisector is a segment, or sorry, let me rephrase it. A perpendicular bisector has to be done to a segment. So segments are the only things that can be bisected, right? Lines cannot be bisected because lines don't have middles. Okay, they don't have a midpoint. But a perpendicular bisector of a segment is a line, a segment, or a ray that is perpendicular to the segment at its midpoint. Okay, so in the diagram here, I show you that EF is the perpendicular bisector of GH. Okay, now what I want to do is I want to explain all the different things that can be perpendicular bisectors real quick, and just making a statement about some situations that confuse people, or they get themselves confused. So I'm going to take let's just say I take a line real quick and just kind of validate or prove, why I can't find a midpoint of a line. If AB is my line, and this thing obviously goes on forever in both directions, right? So this has a feature that says find the midpoint. And if I just click on, well, that didn't do what I wanted. I wasn't clicking on the line. And Control Z doesn't work. All right. So I got my line, and I want to find the midpoint of it. If I click the line's equation, it's the same thing as clicking the line down here. It won't let me click it, okay? Because there are no midpoints for lines. Okay, you can't find the middle position. Because what it's trying to do to find the midpoint is you take the endpoints, you add them together, and divide by 2. Well, I don't know the endpoint of this line, right? Okay, if I look at this ordered pair right there, okay, well, that one's greater, and I can keep playing that game, so I never know what X is to add together and divide by 2. So there's no midpoint of a line. So if I take a segment, though, okay, can I find the midpoint of a segment? Well, what they're doing, if you remember from earlier in the course, we would take these ordered pairs. So let's see what those are. We would take those ordered pairs, we would add the x's together, and then we would divide by 2, and we would add the y's together and divide by 2. So if I take the x value of A and add to it the x value of B and divide that by 2, another parenthesis here, and then I put a comma, and I take the y value of A plus the y value of B and divide that by 2, you see it puts that point right there, right in the middle, right? Okay, so that's the midpoint. Now I've got that set up to wherever I move my segment, it's always going to be the midpoint of the segment. So now I want a line that is going to be perpendicular to that. through C. Okay, so that line right there, and we can ask this to determine what that angle is. When I click on these 3 points, that tells me 270, so I clicked the wrong direction. And you see there that tells me that that angle is actually 90 degrees. And we'll talk later on when we start learning more about angles, how it knows that it gets 90 degrees. But there's some algebra behind the scenes that does it. Okay. So what we're saying is that red line is a perpendicular bisector of the black segment. Does that make sense? Okay. Now, does the red line get bisected? Is the red line getting cut in half? No, because it's a line, right? And we can't find midpoints of lines. And really, any portion of that line. So let's make this a ray. So do that, and I'll hide. So if I look at that red ray that's going on forever in this direction, does it bisect the black segment? Yeah, so that red ray is considered a segment bisector. There, it's still considered a segment bisector. Okay? And it's still perpendicular, so it's still a perpendicular bisector. Does that make sense, everyone? Okay. Now, here's where it gets kind of confusing for people, is if we take... Oh, how can I do this quickly? So I constructed this by using a circle, right? And what is that segment that goes from one part of my circle to another part of my circle but passes through the center? What's that called? If I look at that red segment for this circle, what's that segment called? Diameter, right? And a diameter is made up of 2 radii, right? And those radii are always the same length, right? So by doing it this way, have I forced that red segment to be bisected? Does that make sense? And I can take this distance from there to there, and it'll be 10.87, and from there to there, 10.87, right? So the black segment is perpendicular to the red one, and it's bisecting the red one, right? Is the red one perpendicular to the black one? And does the red one bisect the black one? Are those distances the same? That make sense to everybody? So this is a situation where we actually have 2 perpendicular bisectors. Okay, and I can change these as much as I want, but we now have 2 perpendicular bisectors. But when you have one perpendicular bisector, it does not automatically every time generate 2. Does that make sense? Okay. They have to share to be, for 2 segments to be perpendicular bisectors to one another, they actually need to share the same midpoint. So for instance, if I gave you this segment, okay, we no longer have 2 perpendicular bisectors, right? Only one of those segments is the perpendicular bisector. This is the perpendicular bisector of that segment. Is that okay with everybody? Biggest issue, and I talk about some of these things in the detail that I do because of how many times in the past, in previous years, people get those confused. I know that's going to be an issue for someone at some point when we talk about things that are perpendicular bisectors. Okay. Again, something that's very maybe common sense to us at this point. Let's say we've got 2 parallel lines. Okay, we got two parallel lines right here and here. And I tell you that the transversal creates a 90-degree right there. Okay, so that means that transversal is perpendicular to one of those lines, right? Okay, it's perpendicular to line N. What kind of angle is A and B if I compare them in terms of their position to one another? Corresponding. And corresponding angles have to be what to one another? Congruent. So if one is 90, then the other one has to be 90, right? And if 90 meant that this line here and that line there were perpendicular, then it must mean the same thing when I generate this angle A to be 90, that that line and that line are perpendicular, right? Does that make sense to everybody? So, because we come across that fact so much, we get a theorem. And we word that theorem. It says, if one transversal is perpendicular to one of two parallel lines, then it's perpendicular to both. Okay? And actually, I guess I'm getting ahead of myself. I didn't read this. This is the converse of that. It says, in a plane, if two lines are perpendicular to the same line, so here we're saying that those two lines are perpendicular to one another, these two are perpendicular to one another, that generates corresponding angles that are congruent. And if corresponding angles are congruent, then the lines have to be parallel. Okay? But this theorem works in its converse as well. And I think that maybe is the next one that we write. Yep. Okay, so if two lines are perpendicular to the same line, then those two lines are parallel. Okay? Theorem 310, which again, I don't want you to learn it by the theorem 310, but this says if a line is perpendicular to one of two parallel lines, then it's also perpendicular to the other. Okay? So this is the one, the idea where if that's 90 degrees, and we started with L and M being parallel, then that also has to be 90 degrees because of corresponding angles. And then you have, by definition, two sets of lines that are perpendicular. Are these easy to comprehend? If I'm going too fast, stop me. If something doesn't make sense, stop me. So I want to prove this. I'll give you a minute to write this one down. We'll go through and we'll prove that line C here is perpendicular to line A. So this is a proof. This is kind of a generic proof. It's not something that you would kind of come in contact with a lot in other problems. So it doesn't kind of have enough clout for it to become a theorem or anything like that. But once we are done with it, it is essentially a theorem. It's just not a very important one, so we don't classify it that way. Does that make sense? When we introduce new concepts, new vocabulary words, I like to demonstrate or show a proof that uses those. So when we have this given information that says C is perpendicular to B, C is perpendicular to B, that is a vocabulary word, right? Okay, that even though it's a symbol, it stands in for a vocabulary word. So we're going to figure out if C is perpendicular to B. So C is this one here. Okay, and B is this line here. So what's that tell you about angle 2? Angle 2 is a right angle. Okay, so I'm going to say angle 2 is a right angle. And now I knew that. I figured out it was a right angle because I used that vocabulary word of perpendicular, right? So it's the definition of perpendicular lines. Okay, so that was using this first situation where it said C was perpendicular to B. What about here? B is perpendicular to D. B perpendicular to D. What's that telling me about angle 1? Angle 1 is a right angle. And then D is perpendicular to A, so it tells me angle 3 is a right angle, right? And those are all because we've got those perpendicular lines. Okay, what do you know based off of what we've already talked about? If that angle right there and that angle there are both right angles, what can I say about them? If they're both right angles, they're congruent. So I'm going to say angle 2 is congruent to angle 1. We had a theorem I think it was towards the end of chapter 2. And I think the way I explained it to you was if I gave every one of you a right angle and put it on your desk, and then had any two of you hold yours in the air, those are going to be congruent, right? Any two right angles are congruent because all right angles are congruent. Okay, so that's kind of a statement that we use. So what's that tell me then about lines C and D? They're parallel. So I'm going to write statement number 4 that C is parallel to D. Now, when you guys write this, you might want to condense it a little bit, but I'm going to write if corresponding angles are congruent, then lines are parallel. That might be the shortest way of maybe writing that. Okay, so now here's where this becomes a little bit tricky to see, in my opinion. But if I now have these two lines parallel, right? Those two lines are parallel. Okay? In A was perpendicular to one of them, right? A was perpendicular to D, which is this picture right here, right? I'm just looking at A, part of A, perpendicular to D. If I were to extend that, what's that tell me about A in relationship to C? A should be perpendicular to C. And the logic is one of those standards we just talked about says if a line is perpendicular to one of two parallel lines, then it's perpendicular to both. And the only way that I can see it, I mean, obviously in your picture, maybe that's convincing in the picture, but we can't make C perpendicular to A until we know that those blue lines are parallel. And the only way that I can know that the blue lines are parallel is to make that connection about angle 2 and angle 1 being congruent. Is it okay? The next question is pretty similar. skip that. Let's work with this one. It says, given angle 1 is complementary to angle 2, prove that SX is perpendicular to WX. Okay, this shouldn't take a whole lot of time to prove. So angle 1 is complementary to angle 2. What's complementary mean? So I'm going to say measure of angle 1 plus measure of angle 2 equals 90 degrees. And that's the reason I asked what does complementary mean is because that's the vocabulary word that was in our given, right? And that's what we always need to do. What does that mean for our particular problem? Okay? So we're going to write down the reason would have been definition of complementary angles, right? In order to show that that line right there is perpendicular to that line right there, because that's what we're being asked to prove, we need to show that this is a right angle, right? That WXS is a right angle. Is everybody okay with that? So what I'm going to do next is I'm going to look at my picture and think about what I can do with my picture. And there's not a whole lot that I can do. My picture, if you remember back to the pointers that I gave you, if you're stuck and you don't know what to do, look at your picture. And if it has angles in it, you probably want to use angle addition. So I'm going to write the measure of angle 1 plus the measure of angle 2. Even though we know it's 90 from complementary, we also know that it's the same thing as the measure of angle WXS, right? You guys agree with that? 1 plus 2 is the same as WX to S. And that's the angle addition postulate. All right, what can I replace? So I'm going to rewrite one of these statements. Doesn't really matter which one. Let's rewrite this second one here. What can I replace that with right now based on what we wrote in step 3? WXS. 1 plus 2, as stated in number 3, is the same thing as WXS. So I'm going to write measure of angle WXS is equal to 90. Substitution, right? Okay, so what type of angle did we just identify WXS to be? Okay, so WXS, because I have that feature about it, that characteristic, I can now classify it as a right angle. And when you classify something, you can only classify something or categorize it because you know its definition. I abbreviate right angle a lot with RT and then the angle symbol. If you're confused on what that is. Okay, so now we've classified it as a right angle. What can I now say about the segments? If I have a right angle here, what does that tell me about the segments that make that right angle, or the lines? WX is perpendicular to SX. And remember, because definitions are two-way streets, okay, so I can start with a right angle and know that the sides of it were perpendicular, or I can start with perpendicular segments and know that it generates a right angle, correct? Okay, so definitions are biconditional. So definition of perpendicular lines is going to be my logic there. If I have a right angle, I know by the definition of perpendicular lines, the lines or the segments that make that angle have to be perpendicular. Do you guys remember because this is going to become something that's going to be very important for us in the future. So it might as well, we got a little bit of time right now to talk about it. Do you guys remember what has to be true for two lines in algebra to be parallel? What has to be, what's the feature between two lines? Like if I write the line like y equals, let's say, 2x plus 6. What does another, say it again, what's another line have to have so it's parallel to that? Has to have the same slope, okay? Now, in order to be parallel, it has to have the same slope but a different y-intercept, right? If I use the same y-intercept, it's going to give me the same exact line, right? So we got y equals 2x plus 6, and y equals, let's say, 2x plus, I'm just going to write b here, and let me create a slider for b. And now, any one of those lines there is going to be parallel to that one, right? Okay. Okay, so that's a nice feature that we need to know for things that we're going to do in this class. Okay, later on we get to chapters 5 and 6. Does anybody remember the feature that is necessary if I have like y equals 2x plus 6 again? What has to be true about an equation that is going to be perpendicular to that? They can't have the same slope, right? Okay, so they got to have different slopes. Okay, I need a negative. I need one more thing. And maybe if I typed in my slope this way, it might help you. Because 2 as a slope can be written as 2 over 1, right? Does anybody remember what we had to do with that slope to get a line that is perpendicular? Say it again? So I can't hear you. Flip? What did you say before that? Keep change? What's that mean? Okay, all right, yeah. Who was your was that Mr. Herr? Okay. So 2 over 1 times x plus 6, okay? You're going to, so that's the red line, okay? Which just, there we go. Now, to be perpendicular to it, you're going to take the slope, which was 2 over 1, and you're going to find its reciprocal, okay? Then you're going to negate that. So you make it its opposite, right? Does that make sense? And then I'm just going to add whatever to it again. I'll add that b. But now, when I look at that, so I'm going to ask it for the intersection here of that one and that one, and put some points on here. Is that a 90-degree angle then? Okay. And the idea is that no matter what, okay, I got all those different lines. And you can see if we put the algebra pane back up here, you can see the y equals mx plus b format. No matter what that black line is, okay, the thing that keeps it perpendicular to the red one is the opposite reciprocal slope. Okay. And that's what you're going to hear me phrase it as. If I ask you what are, what's the relationship between two lines that are perpendicular, they're going to have opposite signed reciprocals. Opposite sign, meaning one's positive, one's negative. Reciprocal, meaning I take the fraction and I flip it, right? Okay with everybody? What do I get if I take, if I give you 3/4? What's the opposite signed reciprocal of 3/4? What's the reciprocal of 3/4? 4/3. And if it's opposite sign, one's positive, so this one's got to be negative, right? You see that when I multiply those, it gives me -1, correct? Okay. What if I take 5/2. What's the opposite sign reciprocal of 5/2? -2/5. You get -1, right? Okay. Something we talk about in algebra is if I have a slope, let's say the slope of one line, let's call that line L, is equal to A over B. Okay? Then the slope of line, let's just say T, which I'm going to say line L and line T, L is perpendicular to T. Then it would be B over A, right? And it'd be opposite sign reciprocal. What do I get if I multiply A over B, the slope of line L, times the slope of line T? Okay, A times B gives me AB, right? I'm going to move the negative out front. B times A, can I rewrite that as AB as well? What's AB divided by AB? What's something divided by itself? Close. 1, right? So I get a -1. Okay? So if they ask you algebraically, are these two lines perpendicular? If you multiply their slopes and get -1, then they are. If you multiply their slopes and you don't get -1, then they just intersect and they are not necessarily perpendicular. Does that kind of make sense? Okay. I'm going to open up Math Excel for you, 3.4. My plan is, so maybe, I don't like giving tests on Monday, so probably Tuesday of next week. Probably a test over chapter 3. Okay. Got a few more sections here to run through, but they're not all that difficult.